Now we notice that these variables we used up here, we actually only dealt with positive numbers so far. As we're talking about these stretches, we're only going to be dealing with positive numbers for now. So for y is p times f of x, that's p times f of x. If p is positive, the effect is to vertically stretch the graph by the scale factor of p. Right? That means we're going to multiply any y coordinate by p. That's all that's going to end up happening. And so go, if there's a 2 out front, everything's twice as far from the x-axis, twice as high or twice as low, right? If it's 4, then it's 4 times as far. If it's 1/4, it's 1/4 times as far, or really 4 times as close. And notice then if p is positive, the points are moved away from the x-axis, versus if p is between 0 and 1, that proper fraction, they're moved toward the x-axis. Then if I look instead at this f of q times x, if q is positive, the effect is to horizontally stretch. Both of these we call stretches, right? That idea, it kind of looks stretched, you can see. It's stretched horizontally by a scale factor, and then this one is the tricky one. Don't get too far ahead. The scale factor here is actually the reciprocal of q. Right? Now, when you think about it, think back to what we did on Friday, think back to what we've done kind of before, is that everything on the inside is the opposite, right? Everything on the outside stays the same. You think of even way back when we were doing vertex form of a parabola, this went right h and up k. Everything on the inside is the opposite of what you think you'd have to do, because you have to prepare to undo the process. So if I plug in -4 here, I need to say it goes right 4, because the first thing I do is subtract 4. If I have a times 4 here, I actually need to multiply it by 1/4, because the first thing I do when I plug it in is multiply it by 4. So the scale factor is actually the reciprocal of a number there. And that means if q is greater, then the points are moved toward the x-axis. Right? When we saw that sign of 2x, for example, everything was closer to the x-axis. If I have a proper fraction, then everything's going to be moved away from the x-axis, because I end up saying multiply it by, if, for example, I have sine of 1/3 of x, you would see that you'd multiply all your x coordinates by 3. It's the reciprocal of that. The reciprocal of 1/3 is 3. So let's take a look at examples of what that's really going to look like. So use the graph to graph each new function. So here's my f of x. This says twice f of x. I'm going to take all of my y coordinates, it's outside, so my y coordinates, and multiply them by 2. Right? This is a vertical stretch, in case you want to know what it's called, with a scale factor of 2. So I take this 4, 0, and I multiply the y coordinate by 2, and it doesn't change anything. Right? Notice all my x-intercepts are going to stay the same, because when I multiply them by 2, it doesn't change. Versus what was -2, right, at -2, -2, now I'm twice as far away at -4. What was +2, now I'm twice as far away, I'm at +4. So now I have this new graph. Again, it looks very much the same. That's supposed to be going through this point, my apologies, and through that point, my apologies. But you can see it's stretched further away from the x-axis. Versus, of course, this 1/2 out front. It's out front, which makes it vertical. The multiplying makes it a stretch. And then the scale factor, since it's vertical, is just right there. It moves all your moves my y coordinates, and it multiplies them by 1/2. That's what that means. So I'm going to take my y coordinate here at -4, 0, multiply by 1/2 is still there. I take my -2, multiply it by 1/2, get -1. I take my 0, multiply it by 1/2, and it's not moving. 2, 2, I multiply by 1/2, and I get 2, 1. And then 4, 0, I multiply by 1/2 and still get 1/2. Notice, again, I'm really just using those key points since nothing was changing in between those, right? Since I could use, of course, this -3, -1, this -1, -1, this 1, 1, and this 1, 3, 1, excuse me. But since they lie on this straight part of the line and that straight part of the line and that straight part of the line, it really doesn't matter. It's not going to change too much. Notice those were all vertical stretches. This inside part is going to recognize that really I'm dealing with horizontal stretches right now. Again, multiplication means stretch. Horizontal because inside. So my scale factor is the reciprocal. So what was -4, 0 is now multiplied by 1/2. Right, I'm just changing the x's. So when I was at -2, -2, I multiply my x by 1/2. Of course, anything through the origin when you multiply, whether it's vertical or horizontal stretch, it's not going to change. What was 2, 2, I multiply my x by 1/2. And what was 4, 0, I multiply my x by 1/2. And so we can see this horizontal stretch. It looks like it's being pushed towards the the y-axis. And here we have another horizontal stretch with a scale factor, again, reciprocal. So of 2 means I take all my x coordinates and I double them. So what was -4 is now -8, -5, 6, 7, 8. I have to do my best to get this -8 out here. What was -2, -2, I double that x coordinate and I get -4, -2. Again, I'm not changing my y. It's just affecting the x. The origin, as I just mentioned, is not going to change. 2, 2, when I double my x coordinate, becomes 4, 2. And 4, 0, when I double that, becomes 8, 0. So 5, 6, 7, 8. Right, if I extend this axis out, here's my 8. And again, we connect the dots because they were already connected to begin with. Right? So since we know that these are connected by straight line segments, I can draw those. So again, just that reminder of how we went through these. This outside is going to affect the vertical, right? You can tell it's taller or shorter. Versus if we have inside, it's going to affect your x. You can tell that it goes closer to the y or further from the y-axis.